Alright, now we're cooking. We keep it stirred. This is going to take a while to burn off that much plastic, but seems to be working well. Well, hello scrappers, Mike here. Welcome back to my channel. And today we're going to process some tantalum capacitors and see how much silver we can recover from them. And I've got quite the accumulation of tantalum capacitors over here. They have been building up, I would say, probably for a couple of years. So I got one bag here, mostly yellow ones, one bag here, black, yellow, orange, blue, sort of a mix. I'm just going to process them all. We're not going to worry about the colors on them. We're just going to see how much silver we can get out of this whole batch of tantalum capacitors. First thing we need to do, though, is figure out just how much we've got here so we can calculate a yield down the road. So, got scale over here. Let's get it fired up. See what we've got. Is that readable? Yeah. Okay. So this yellow bag. And yes, Richard, I know I'm weighing the bags. You don't have to remind me. All right, so we got 2,404 grams. This on here. Wow, we're just short of 4 kilos of tantalum capacitors. That's a lot of capacitors. I'm starting to wonder if I want to try and process them all in one batch. I had a lot of trouble the last time I processed tantalum capacitors, so I'm thinking maybe I want to scale back a little bit. Maybe we'll just do one bag. What's this bag of mixed ones weigh? Not quite 1.5 kilos, 1,462 grams. Let's process this, and if everything goes well this time, because like I said, I had problems before, we'll process these maybe in the next video, okay? So let's just process this bag to start with. So what's the first step in the process? Well, I think the first step is going to be incineration. I think I want to incinerate these and get rid of all the plastic on them, the plastic outer shell, and just expose the inner tantalum and silver goodness. Now, the last time I did this, I had a lot of trouble with foaming in the beakers I was working with. And all I did on these last time was just crush them up into a powder, including the plastic. And I think the plastic powder was giving me trouble with the foaming. So this time we're going to burn that plastic off and get rid of it. And we'll see if we have less trouble with foaming when I process these. So let me get set up for incineration, and we will take these over there and we will cook them in my foundry furnace and get them well incinerated. All right, so how am I going to incinerate these? Well, I've got this thrift store Dutch oven I bought a while back, and I've been itching to use it. I got it suspended over my foundry furnace with some pieces of rebar. And I'm just going to try burning these in open air. We'll see how it goes. This furnace gets really, really hot. I suppose it's possible the cast iron Dutch oven might crack. I've cracked frying pans doing this. We'll see how it goes. Let me put around half of these in here. I'll have to keep it stirred so the stuff on the bottom burns too. But we'll see how it goes. If this doesn't work, I'll find another way to do it. Okay, let's fire this thing up. Burning daylight here. Let me turn the heat up. And we'll let this get hot. I'll get a stir stick. And we'll see how all this works. If it works at all. Well, it's been a couple minutes. We're starting to get some smoke. I put a couple scrap pieces of fire brick up there to help direct the heat up around the Dutch oven. So we'll see if that works better. It looked like a lot of the heat was just coming out around it. Not much was happening. But yeah, I think they're heating up now. So Got a good stiff wind blowing any smoke away from my neighbors today, so that's a good thing. We'll see how smoky it gets, though, once this gets really hot. All right, now we're cooking. We keep it stirred. Smoke level's not too horrible, so that's good. Okay, this is going to take a while to burn off that much plastic, but seems to be working well, at least so far. Okay, I put a wire mesh screen over it because we're sort of getting a popcorn effect, and a lot of pieces are popping out into the grass. So I guess they're just exploding in there under the heat. I've turned the heat down a bit because this was going pretty rapidly. So, but yeah, this is cooking a little faster than I expected, and with not quite as much smoke as I expected, which is great. Okay, let me turn the heat off so I don't get burned doing this, at least less likely to get burned. Bloody hot. You see if my Kevlar gloves here can handle the heat, at least for the time it takes to dump that out and get it back up there. Woo, yeah, that come right through the gloves. Okay, ouch. All right. Yeah, that's hot. Okay, so put these in, start the process up again. Get the heat going. There we are. All right, we'll get the second half process just like the first half. Cooking already. That Dutch oven's red hot. Yeehaw. Oh, look at it, burning already. This is going to take, I don't know, less than 10 more minutes to do this half. Let me get the screen back up on it in case of popcorn it starts again. Give it a good stir first. And away we go. Be back when they're done. All right, I've got this stuff incinerated. It's cooled down. Where do we go from here? Well, I'm thinking the next step needs to be to crush this stuff as best as I can, to release as much silver inside the bodies of the incinerated capacitors as I can. So how am I going to do that? Well, there's lots of different ways you could do it. I just happen to have a ball mill. Okay, it's a home-built ball mill, just cheap Harbor Freight vibratory tumbler, and I don't know, 20 pounds of various size steel ball bearings inside. That's my ball mill. And I've used it, if you watch my videos, you see me use it for crushing up incinerated IC chips. Works great for that. So I think what I'm going to do is I'm going to put a few handfuls of the incinerated tantalum capacitors in there and run it and see how well it does on them. I have no clue whether it's going to work or not. This is an experiment, and we'll find out together. So here we go. I have found with the IC chips, it does not pay to overload this thing too much. So I'm going to put about 3 handfuls in. Yes, a mic handful is a scientific measurement. Yes. So that's 3 mic handfuls in there. You put the lid on. And I'm thinking to run it for at least an hour and see how it looks. See whether it's really crushing everything up or not. Sometimes I go as long as 2 hours with IC chips. You don't want to go too long, though, because this thing will pulverize stuff to the consistency of ink particles. And that's really hard to work with when it's that fine. All right, let's start it up and let it go for about an hour. Yeah, it's really noisy. I'm going to go do something else for a while, a ways away from all this noise, and check on it in an hour or so. Alright, this has run for not quite an hour. And it's gotten dark out here. It's going to rain in a little bit, so it's gotten gloomy and dark. So it's a little dark down there, I know. But look. The incinerated tantalum capacitors have been reduced to dust for the most part. There are some lumps there still. Those are probably the end electrodes. What I can do, since this is a fairly coarse dust, is I can let it run for maybe another hour. And then we'll see how it looks. Maybe there'll be fewer lumps down in here. Well, there really aren't that many. There's a few. But yeah, maybe let it run another hour, and then we'll see how it looks. I might do that tomorrow, because I think I need to head for the house because it's about to rain. Alright, so this has run for about another hour. Let's take a look at it. Alright, so let's have a look at this after about 2 hours of running. And I still feel a few little lumps in there. But boy, this powder's getting fine. So I think that's about as much as I want it to run. I don't want this powder to get too fine that it's... Ooh, look at it stick to my gloves. And on my arm, too. That it's impossible to work with. So, okay, so I'm going to get the powder out of here. So how am I going to do that, you might be asked? Well, let me show you. So basically what I'm going to do is I'm going to vacuum the dust out. I've got my shop vac over here. And I've got a cyclone separator. It's called a dust deputy over here. So as the dust comes out, it's going to get separated from the airflow by this cyclone on the top. And it's going to drop into this canister. And mostly just clean air is going to go into the vacuum cleaner over here. So that's a beautiful thing. So I can just vacuum the dust out and put another load in. I have found that this works better with the ball mill running, because the dust is much more mobile with all those ball bearings bouncing around in there. So it's going to get a little loud, but I'll show you how this works. Let me start the vacuum. Start the ball mill. Alright, that's pretty good. I got almost all the dust out of there, just a little bit left. So now it's all over here in this canister under the dust deputy. And what I'm going to do is I'm just going to keep this up until I work my way through all of these incinerated tantalum capacitors and all the dust is in there. Then we'll go on to further processing the dust. So it's time to put about 3 more mic handfuls of incinerated tantalum capacitors in here. Try not to breathe the dust. Close this thing up and get it started again. So we now know that it takes about 2 hours. Do a pretty good job of turning this stuff into dust. There's still some lumps. Some of those lumps, I think, are the end caps on the tantalum capacitors, which are probably steel, where they get soldered onto the boards. And some of them may just be capacitors that haven't been totally converted to dust. Either way, there's not that much. There's mostly dust. And I think the stuff that's in there is small enough to process. So let's get this started again for 2 more hours. Well, it's been another 2 hours, so let me vacuum out the remains and put in another load. I'm just going to keep this up. So I don't know how well you could see that because it's dark down there, I know, and everything in there is black, but the vibration of the bouncing ball bearings makes the powder climb the sides of the walls of the thing, and it makes it really easy to just vacuum it off. Put a little bit more in. Those were some substandard mic handfuls. Probably got about one more load here, then we'll be done. All the powder will be in the canister under the dust deputy. Is the only way to do this? No, of course not. There's lots of different ways to pulverize these things. But I just happen to be set up for doing it this way. It's the same process I use for IC chips. After I incinerate them, I pulverize them in this and vacuum the dust out. Then I process the dust. So I have like 100 pounds of IC chips I need to process. I've processed hundreds in the past, so I'm set up for bulk processing of IC chips. And, well, this seems to be working for the Tantalum capacitors too. All right, 2 more hours on this, 2 more hours on this, and I think we'll be done and ready to move on. So I'll be back when we're done. Okay, so I have crushed all of the tantalum capacitors I incinerated through the ball mill and vacuumed them into this. Let's have a look and see what we got inside. Well, we've got a whole lot of very black dust in there. Okay, so what is the next step, you might be asking yourself? Well, I think a lot of this black dust is going to be ash, which I want to get rid of. And just stick with the metal. The tantalum, the silver, the steel, the copper, whatnot. Just get rid of the ash. I mean, the rest, a lot of those metals are in the way, but at least the ash is easy to get rid of. So I'm going to dump this stuff into a 5-gallon bucket, and I'll give it a series of gravity separations just to get rid of the lightweight ashy stuff. And we'll keep all the metallic portion, and then we'll treat that to recover the silver. So I'll show you how I do that after I dump this stuff into a 5-gallon bucket. Alrighty, it's time to do a gravity separation on this stuff. So how does gravity separation work? Well, got my bucket full of black powder here. Now this black powder is made up of metal powder and ash. We're going to take advantage of the fact that the metal powder is denser than the ash. So if I fill this bucket with water, well, maybe halfway, there's not that much stuff in there, and then give it a good stir with my drill with the stirrer attachment on it. Once I stop stirring, the ash is going to spend more time in the water than the metal. The metal is going to drop out fairly quickly. The ash is going to stay in the water for a while. I can pour that dirty water off after I give it a little bit of time for the metal to settle out, and we'll get rid of most of the ash. If I do that 2, 3, 4 times, we should get rid of almost all the ash in here and just be left with metal powder. So that's how gravity separation works. So I'm going to put a little bit of jet dry by finish in here, and that will help break up the surface tension of the water, and that will prevent stuff from floating. I don't want it to float. I want it to sink at its own rate. Metal fast, ash slow. But this stuff might be a little hydrophobic, so it might want to float. So the finish will help fix that. And when I pour the water off, I'm going to pour it into this little bowl right here and let it overflow. So any solids, any metallic solids that I get out of here accidentally pouring it off will collect in the bottom of this bowl, and rather than being lost. So I can always put them back in, and we can do the process over again until we're basically dumping off clean water. And what's left down here is metal powder. So that's how the gravity separation works. It's pretty simple. And let's get started. Okay, in goes the water. Okay, bucket's not quite half full. I think that's probably enough. Yeah, there's a bit of an oily film on the surface. Might not have completely ashed those chips. We might have turned some of the plastic into pyrolysis oil. So that's going to cause stuff to float, but the jet dry, that just breaks the oil film up something wonderful. And stuff's not going to float now. So let me give it a good agitation with this. By the way, all the equipment I'm using, there'll be links to it in the video description. So you can acquire this if you want to do it this way or do it a different way. Let me know how your way works. Agitate it really good. Get everything up in the water. Now I'll just give it a few seconds for the heavier stuff to drop out. And then I will pour off the dirty water. I'm not going to pour all the water off. That's maybe 2/3 of it. And then we're going to do it again. Oof. Black water spraying up my arm here. All over my clothes. It's definitely a little bit messy. Fortunately, I'm wearing old clothes, so it doesn't matter. Put a little more jet dry, and by the third or fourth of this, we shouldn't need the jet dry anymore. Okay. Again, we give it a good agitation. Give it a few seconds. Let the heavy stuff settle out. The light stuff will stay in the water. And gently pour off the dirty liquid. Any of the values, the heavy values that we want that do manage to come over, they're going to stay in the bottom of this second bowl here. And I can recover them later. So, that's the process. I'm going to keep this up until, like I said, I'm dumping off pretty much clean water. So that's going to take another few separations. So you don't have to watch it all. I think you got the idea. Be back when it's done. So I kind of lost track of how many times I've done this now. 5, 6, I'm not sure. But as you can see, the liquid is coming over a whole lot cleaner. Just got a little bit of sediment in it. And there's our leftover stuff down in there. I could probably wash it a couple more times, probably wouldn't hurt. And I might do that. But yeah, we're getting down to it. There's a lot more lumps in there than I thought there were, in amongst all that ashy powder. So I'm thinking that the tantalum capacitors don't break up that well in the ball mill. So I never tried doing them in the ball mill before. But yeah, I'm thinking those lumps of sintered tantalum, they just don't break up all that well. Maybe I'll make this the last wash. Then we'll see what's in the bottom of that bowl there. See if any of those lumps came over with the rinse water. Give it a few seconds here. Although the water's clearing up pretty fast. Oh yeah, that's looking pretty clean in there. All right, let's see what's in here. Whole lot of nothing. All right, so we left all the heavies in there, so that's great. All right, so let's go back over to the lab and get this stuff into a big beaker so we can start treating it to try and extract the silver I know is in there. Okay, I'm going to transfer this stuff into my big 3-liter beaker here. And I'm using distilled water from here on out. I did my gravity separation with tap water, but we don't want any chlorine in here in this process. So from here on out, everything is distilled water. In fact, I will give this stuff a final rinse or two with distilled water just to get any of the chlorine from the tap water out of it before we proceed with the recovery of the silver. Get every last little bit out of there, because some of these little foils in here could be silver electrodes. Okay, that's looking like a pretty clean bucket there. A little bit more stuff here. Come on, everybody into the pool. There we go. All right. So I'm going to drain this off and give it one more wash with some distilled water. And that should be pretty chlorine-free now. At least chlorine-free enough for my purposes. Okay, so let's get this stuff in the fume hood and see if we can recover some silver from it. All right, so got the stuff in the fume hood here. I'm going to add some more distilled water to it. Get it all submerged good. We're about to try and dissolve all the metal in there that will dissolve with nitric acid. Now, the silver will definitely dissolve in nitric acid. There's probably some iron and some copper in there from the end cap electrodes. Might be some tin. There's a lot of tantalum. Nitric acid won't touch the tantalum. Tantalum is a very resistant metal. The nitric acid won't affect it. So we'll just be dissolving the silver and the rest of the base metals in there. The tantalum will just stay behind. Not much you can do with tantalum. It doesn't dissolve in common acids, and it has a very, very, very high melting point. So there's not much the amateur can do with tantalum. But we'll see if we can get the other stuff out. Let me get the fume hood going here. Because we're about to make some fumes. I'm gonna leave the heat off. Actually, I was gonna turn the heat on, kind of out of reflex, but I think I'm gonna leave the heat off to get a better view here of what's going on. And we're gonna put some of my homemade nitric acid in there. I have a video, put a link in the upper right up here, to how I make my nitric acid. From time to time, I set up all my apparatus and make my nitric acid with fumes. And we're gonna put some in. And look at that. Oh yeah, look at that. Now I'm going to put this bowl on here just to keep the fumes in, reflux a little bit. Fumes can still come out the spout there, so it's not sealed. Look at the fumes. Wow, yeah. And this is cold. This is all stone cold. I'm glad I didn't turn the heat on because this reaction could really get out of control. Although once it starts settling down a little bit, I will put some heat on it and help dissolve the metals. But hey, speaking of dissolving the metals, look close there. I don't know if you can see that. The liquid's already turning blue-green. Oh, and it's got it quite warm too, without even the heat being on. So, yeah, the nitric acid is attacking those base metals in there. It's going to dissolve the iron and the copper first because they're more reactive. Once they're all in solution, the silver will start going into solution. So this may take a fair amount of nitric acid. I don't know if we'll use up all this, but I do have more if we need it. I always wait until I have a lot of nitric acid on hand before I start a project like this. Okay, so we're just going to let this sit here and do its thing. When the reaction dies down, I'll put more nitric in. And then when the reaction dies down, I'll put more nitric in. I don't want to put in too much at once and have it foam up out of the beaker, which it may be trying to make some foam anyway, so I better keep an eye on this and not walk away from it. Okay, so you know what's going on? I'll be back when something interesting happens. Okay, here's something I was expecting to happen. As you can see, the liquid is starting to turn reddish orange, and we got some orangish foam on top there. So what's happening here is there was iron in there in the form of the end caps on the capacitor. If you wave a strong magnet over a pile of tantalum capacitors, you'll find they stick to it. It's because they have steel, which is basically iron, as part of the end cap components. Now, you may be asking, Mike, why did you use a magnet to separate the iron out? Because the iron is bonded to the silver, and I'm afraid I'll be pulling the silver out with the iron, and it's what the silver is what I want to get. So we're just going to have to bite the bullet here and let the nitric acid dissolve the iron. So iron is probably the most reactive metal in there. After that would be any tin that's there, and after that would be any copper that's in there, and then silver would be at the bottom of the list of elements that are going to react with the nitric acid. The tantalum's not going to react. So like I said, we just got to bite the bullet and let the nitric acid chew up the iron and chew up all those other metals before it starts chewing up the silver. And what's happening here is it's of course turning the iron into iron nitrate, but nitric acid being such a strong oxidizing agent is actually further oxidizing the iron to iron oxide, or rust, which is why we're seeing this color change. We're getting rust in there. But anyway, it's been, I don't know, 10-15 minutes. The reaction's still going strong. It's boiling hot, even though I have not put any heat to it. So just going to let it go until the reaction stops entirely. Then we'll hit it with some more nitric acid. But I think things are going good, pretty much exactly as I expected. We just got to work our way through all these base metals before we get to the silver. And this stuff is really hot too, even though I have not turned the hot plate on. Let's see what kind of temperature we got going on here. 90 C. So 10 degrees below boiling, even though I have not put any heat to it. So that's just the reaction of the nitric acid with the base metals in there. It's quite energetic. And it's still going on. It's been about another 10 or 15 minutes since the last segment, so not time to add more nitric yet. Alrighty, it's been maybe another half hour. I had to leave and go to the hardware store, come back, and the reaction looks like it's pretty much done. It's cooled down a lot. It's also looking pretty gloopy in there, pretty thick. Yeah, so I think we've got a lot of iron oxide suspended in the liquid there. So I'm going to put some more distilled water in, just to try and thin that out some. And we need liquid for the metal salts we're making to go into solution. So I'm going to put some more nitric acid in. Another shot about like last time. And well, the reaction is a lot less vigorous. So I imagine we probably got a lot of the iron in solution. The iron would have been the most reactive metal in there. So we've probably got a lot of that taken care of. We're probably down to tin, copper, and silver. Any other base metals that are present in the tantalum capacitors. So this reaction looks a whole lot more sedate than the first one. I'm actually going to put some heat to it to try and speed things up. Not too much, a little bit. And this, like I said, we'll probably let this go until the end of the day, until it's time to shut down for the night, and then pick up with it tomorrow.